All right, let's see. It's gonna be an easy today. And there's been like no mediums for a while, which is my zone, I think. Oh, anyways, prime number of set bits in binary representation given to integers left and right. Return the count of the numbers. Return the count of the numbers in the inclusive range of left to right, having a prime number of set bits in their binary representation. Set bit being, recall that the number of set bits an integer has is the number of ones present when written in binary. Okay. Count the number of in the inclusive range having a prime number of set bits. For example, 21 written binary is 10101, which has 3 set bits, which is a prime number. So 6 to 10 have 4, or 6, 7, 8, 9, and 10. No, so not 8. 6, 7, 9, and 10 all have a prime number set bits. Sure. 10 to 15 have 5. Okay. Let me think. Let me think. So I'm just going to go and list off, let's say 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see what it can detect about how many set bits there are. So let's say this is 1, 1, 2, 1, 2, 2, 3, 1, 2, 2. So let's see, what powers of 2? This is the power of 2. That's the power of 2. Well, maybe I probably need to do one more set here. That's 10, 11, 12, 13, 14, 15, and then this would be 16. So 2, 2, and then there's a, no, this is a 3. 2, 3, 3, 4. I'm trying to figure out when it kind of levels up. So somehow it levels up. Um, 1, 2, 2, 3. And it goes back to 2. 3, 3, 4. Do I need another set? Alright, I think I need another set. Well, I mean, actually, right, the next set is just going to be appended to what? It should be this stuff 1 subtracted, right? Because this bit in the next set would be without the 8-bit being on. So it would be like this is 1. So I mean it should be like this, but with like an extra 0. like a 0 here. Oh no. So it's not this one, it's this one. So it's here, there's a 0. So am I counting right? It's this 1, 2, 2. So, I see, I see. So the first half is the same thing as the prior set. And then the second half is the first half but added with 1. So 1, 2, 2, 3, so it'd be 2, 3, 3, 4. So first half is 1, second half is added to 1, 2, 1, 2, 2, 3. So here it'd be like 1, 2, 2, 3, 4, 1, 2, 2, 3, 2, 2, 3. So that's the first half, and the second half would be something like 2, 3, 3, 2, 3, 3, 4, 3, 4, 4, 5. Okay. I think this, so it seems like it'd be kind of recursive maybe. This is easy. I guess maybe they have oh no, it's not even a very finite range. I mean, I wonder what I guess the simple way of doing this would be, or the iterated way, O(n) way of doing this would be to just iterate through all the values, like for every value in range left to right plus 1, so it includes left to right value. It'll be something like answer equals 0. I'm guessing because it's up to 10 to the 6th, then the primes that could be on, let's say the primes that would be 2, 3, 5, 7, right? I guess it could be more. 5, 7, 11, 13, 17, 19. I'm just doing all the ones up to 32 bits, I guess. 23, 29, 31. Okay, just have all sets. If the value dot bit count is in the primes, then answer plus equals 1. Turn answer. That's gonna be the simple way of doing it. And see how that actually fares. Huh. Fares pretty darn well. Wonder if I can optimize this. I can. Definitely can. I guess left to right. Actually, it's only 10 to the 4th right, so 10 to the 3rd is 1,000, so 10,000 values. So it's doing this approach for 10,000. But I think I can optimize it slightly better. So it breaks down into these ranges. How would I break this down? So feels like recursion, but then recursion kind of compresses the range. Recursion compresses the range. So 1 is not prime, right? One set bit being on. One set bit is not prime. And 1 occurs at every power of 2. 1 occurs at every power of 2. So, and then the stuff that is Mamma mia. So if I broke the range into powers of 2, broke the range into powers of 2, so like 6 to 10 becomes, let's just do something somewhat slightly harder. Let's do 10 to 100 is left, right? So that means I have 10 to 15, 16 to 31, 32 to 63, and 64 to 100. All right. So if I look at like 16 to 31, let's say there's some sequence for that. 16 to 31. 16 to 31 sequence, however number, let's say there's X number of values that are that have prime set bits there. This is going to be the same as if I break down 32 to 63, this breaks down to something that is kind of a first half and a second half. Where the first half is going to have X as well, because it's going to be repeating the same sequence of, the first half will have the same sequence of binary set bits for those values. So then the second half will have, it's not going to be X. I almost want to say, is this, well, ugh. Ay caramba. It's not quite pre-computable. Is it pre-computable? Not pre. I don't see. What does the second half have? It's gonna be one, one, two, one, 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 two. The number of ones in the next bracket is going to be 1. There's always only going to be 1 in each bracket. So if I think of this as the number of zeros, ones, and twos, there's like 0 zeros, there's 1 1, maybe I'll do this. There's 0, there's 1, there's 1, there's 1, and there's 2, there's 1. This is basically set bit and the frequency. So now there's 0, there's 0, sorry. I think it's 0, 0. Maybe I don't actually need to type the space, it's harder. 1, there's 1, 2, there's 2, 3, there's 1. I think it's the so I increase, I keep the same thing. So 1, 1 and 1 2, I keep that, and then I also increase the frequency by, I take the value, the set bit value, add 1 to that, and increase the frequency by 1. Alright. 1 goes to 1. Not quite. It's these frequencies plus these frequencies plus 1. But then how do I get the 1 here? So there's 1 1 and 1 2. Oh, okay. Wait, is this binomial? Binomial 1 3 3 1. Yeah, it is, right? Oh my god. I'm a dum dum. There's 1 1, there's 3 2s, 3 3s, and 1 4. So 1 3 3 1. Oh my god. And here it should be something like 1 1, 4 2s, 6 3s, 3 6, 6 3s, 4 4s, 1 5. Okay, probably should have recognized that earlier. So that's the overall frequency, right? That's the overall frequency within a bracket, where the bracket extends from power of 2 value to next power of 2 minus 1. So how do I do the, how would I do the partial brackets? Like 10 to 15 rather than 8 to 15. I mean, if I'm doing the partial brackets, then it's either going to be the partial. Oh, I see, I see. I think I see. So 10 to 15, or actually let's do 64 to 100 because I think that might be slightly easier. 64 to 100 partial bracket, where bracket equals kind of 2 to the power 2 to the n to 2 to the n plus 1 minus 1. So like between powers of 2. The first half of this bracket the first half of the bracket is going to be 64 to, so if I divide it into two halves, 64 to 96-ish, 64 to 95 inclusive. And then 96 to 100. This first half is the same as the previous bracket. So it's the same as 32 to 63. However, whatever the value there is. So then it boils down to the 96 to 100. 96 to 100. I mean, I could just do a loop for that. Seems like I did most of the work though. Okay, let me think about it. 96 is going to be 164, 132. And then a bunch of zeros. So the 96 is basically setting this. 96 is basically setting this to setting a number set bits, right? Setting 2 set bits, and then I'm dealing with something that is 2 plus like 0, 0, 0. So there'd be 1 through 4 here. Oh my gosh. I mean, oh, okay. All right, so I think what I want is all right, so this is, I'll say this is the most straightforward way. That is very well, comparatively. Let's go ahead and I think what I want is to pre-compute Pascal's triangle. I think it's probably doable in terms of space. Kind of binomial coefficients / Pascal's triangle. So let's say the current is equal to 1, and then for every, let's say, row in range 31, 32, 31, the next row actually let's say the coefficients is going to be a 2D array. So next row is going to be, actually I do need a current row. So next row is going to be, it needs to start off with current. So do I need to make a copy? Can I somehow make it? Can I somehow do a list comprehension here? So next row starts with, maybe I need to add a 1 to the current row. Current row appends a 1. So now it becomes a 1, 1. I think. So let's do something like, let's say it's 1, 3, 3, 1. I know this is not correct syntax. So if it's a 1, 3, 3, 1, I need to add its values staggered. Add its value staggered. So maybe I do next row starts with a 1. Next row starts with a 1. And then for every okay, so 1, 3, 3, 1, and then it needs to add 1, 3, 3, 1. Three, 3, 1, 3, 1. So it needs to do something like for every index in range 1 to the length of current next row dot append current at this index plus current at the index before. So 3 plus 1, 3 plus 3, 1 plus 3. And then next row needs to add another 1 at the end. And then current becomes next row. And then coefficients appends this next row here. Oh, that's not going to work. Whoops, incorrect syntax. As well as that. Okay. It's really not what I expected. Okay, it's appending the memory location. It needs to append the copy of the next row, I think. Well, that didn't work, huh? Actually, it starts with a new memory location each time. So why didn't it work here? Why didn't it work there? 131. I mean, this does seem to be... Oh, I'm printing out the wrong thing. Print out current rather than print out the coefficients. Okay. Yeah, okay. Looks like it's too big. Well, is it too big? How many values would this be? I mean, it's actually, let me see. Does this run? Does it run? Okay, so I mean, it doesn't run out of space. So here, okay, that's the pre-computation a bit. Okay, anyways, so that's the pre-computation. So I think I can use this. I think I still need to know primes. So I'll say answer equals 0. I'll actually just copy this here. Still need this. Do 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 do. So if I were to make this faster, um, I guess I would just iterate through for each bracket, right? For each bracket. For each bracket, it arranges through. So 6 to 10, I would need to bracket it for things that it has that's whole. I wonder. Yeah. Trying to think if I can recursively do this. It's not quite recursively. I could just come up with the distribution of every set bit frequency. Distribution of set bit frequencies. And then just count there. I guess. Do 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 do. All right, come on. Coming up to the issue of the partial brackets. I don't know if I really did a. I don't know if I actually came up with a way to do this. So if there's a partial bracket, you find what do you find here? Hmm. Okay. So if it's a partial bracket for no, this doesn't work. So if it's a partial bracket where it's inclusive of the lower end, the lower power of 2, up to some mid value between power of 2. I was thinking maybe you can somehow use the distribution of the next bracket, but then that definitely doesn't work. For everything up to the first half, you can use the distribution of the lower bracket. But then if it's not even filling the first half, then you can't use it. So if this was like 64 to 80, it doesn't actually reach the full first half, and then you can't use the lower bracket. Lower bracket being the bracket that is like 2 to the power 1 less. I mean, this could just iterate, do the slow way. Avoided using a slow way though. What's the point of doing this direct calculation if I don't skip all the slow iteration? I think maybe 32 is maybe too much. What is the most reasonable upper bound here? Yeah, whatever. 32, 64 to 100. Yeah, I think what I just need to do is make a helper function. Helper function that returns the appropriate distribution. Okay. Fine. Set. Let's say, yeah, find set distribution. Let's take in a low value, a high value, and returns the distribution. I guess maybe I should probably keep this outside, so that's just a global. Okay, this is going to be helper function, returns the distribution of set bits, basically a 2D array, or I could use a default dictionary. I guess I'm passing back an array. Maybe it should be a default dictionary. Where the value is, where the key is the set bits, and the value is frequency. I think I'm going to go ahead and require that the low and high are powers of 2, or powers of 2, kind of ish. Okay, so I think I need to convert the power of 2 into a number, an index into my coefficient. So like 90, like 64 should convert to 5, no, to 6 maybe. So what is this? I think I screwed this up. Okay, yeah, this is 1, so this 2 to the 0 here. 2 to the first, 2 to the second minus 1. So if it's 1, so I think it's log base 2 of the number. Yeah, I think it's log base 2 of the number. Where's my code? So the index should be, actually I'll say this is the row index. Should be log base 2 of low. How do you do this? Math. Does this return an integer? No, it returns a decimal. So I think I need to just convert to integer maybe. And also use log x comma base, specify the 8 base number. However, the dedicated log 2 is generally more accurate. Sure. Okay. Math.log2. I guess math is already imported. So log2 of low cast to an integer. And I think that's it. Coefficients of this row index. Guess I wonder why I need to actually do this. So whatever. I'll say instead of frequencies, I'll say set frequencies. So 64, log base 2 of 64 is 6, row index 6. So 0, 1, 2, 3, 4, 5, 6. Okay, that seems reasonable. 64 to 128, 63 values. Yeah. Should be 64 to 64 to 128. 64 to 127 inclusive of 64 values, right? Yeah. Okay. Okay, so I think here like here I can do something like I need to break it up into ranges. So break it up into ranges. Gosh, okay, so I'll do the hard one after. Now, if it's 64 to 95, how would I break it up into ranges? So something like for every power in range, for every power in range, like 32. Okay. Guess maybe I should just do powers of 2. 2, 1, 2, 4, 8, 16. Oh gosh, 32, 64, 128, 256. Alright. Alright, this is annoying. Alright, this is one I'm actually gonna just take a pause on. I'll come up with something better.